All right, today's objective is I can find the zeros of a polynomial function, both real and complex. So that is exactly what we are going to do. So let's jump right in. Just as a reminder, the number of roots of a given function is equal to the degree of the function. So number one here, the degree here is 4. Remember, degree is the highest exponent, so it would have 4 roots. Degree here is 3, so it would have 3 zeros. Okay, last one, can you type this into the Edpuzzle, please? Would be 5 solutions. So if you remember back in our talks at the beginning, we had talked about the degree being the highest exponent, right? And the highest exponent telling us how many solutions there are. We also said, just for a brief second, that not only could the solutions be real solutions, but they could also be imaginary or complex solutions. So if we remember back to a quadratic, we said that quadratic has real solutions if the graph crosses the x-axis. It has imaginary solutions if the quadratic does not cross the x-axis. Well, what's cool about that, we already know that a quadratic is a polynomial, right? It's just a polynomial with degree 2. The same thing happens for polynomials with higher degrees. So for example here, we know based on what we had talked about with the number of increasing and decreasing intervals, 1 increasing, 2, that's a decreasing, and then 3 is an increasing. We know that has a degree of 3, right? We can also look here at the actual degree and the function. So we know the degree is 3 based on the increasing and decreasing intervals, also based on the fact that it says the degree in the actual function. Well, what that tells us is that there are going to be 3 solutions, or 3 roots, or 3 zeros, okay? But what it also tells us, if we were to look at the graph, we can't figure out from the function, we can figure out from the graph, is that it's only going to have one real solution. And the reason it's only going to have one real solution is because it only crosses the x-axis one time. Okay, right there. Does that make sense? The other 2 solutions are going to be imaginary. So this is where we have to put everything that we've learned so far into play. Okay, so it says, what's wrong, what's going on? Well, it doesn't cross the x-axis 3 times, therefore there's going to be some imaginary. So find all zeros, state the number, and type. Well, number 1, we do know one of the real zeros, right? The only real zero, actually, is -4, right? Because this is -1, -2, -3, so it looks like the polynomial crosses the x-axis at -4. Since it crosses the x-axis at -4, so that's x equals -4. Since it crosses the x-axis at -4, that's a solution, yes? Well, what factor do I know happens or comes from the solution of -4? Well, that's x plus 4. Do you guys all agree if I were to set this equal to 0, right? So our goal here, again, the only way, and I'm sorry I didn't say this at the beginning, but the only way we know how to find imaginary solutions is if the function or if the equation is quadratic, right? That's the only way, and how we do that is to use the quadratic formula. Well, in our original here, we know we have 3 solutions, one of which we found is real. We know the only other way to find imaginary solutions is to get this thing to a quadratic, right? So we somehow have to bring it down a degree. Well, how in the world are we going to do that? Luckily, we learned something the last couple days that has to do with division, specifically synthetic division. Do you agree that if this is my solution and this is the factor with which that solution comes from, can I divide that factor out of my function? I can, right? And then all I would be left with are the imaginary solutions. So I essentially take out the real, and all that's left is the imaginary, and it just so happens that the function I'm left with is a quadratic. And since it's quadratic, can I now find the imaginary solutions? I can, right? All right, so let's do that. So let's use synthetic here. If I were to use synthetic, remember what goes in this box is the solution of -4, right? Okay, and then the coefficients go alongside, so that's 4, 18, 9, and 4. Bring down the 4. That's negative 16. 2 is negative 8 is 1. I get negative 4 and 0. Okay, now hopefully everybody in here, you guys understand that that should be 0 as a remainder, right? Because if this is a solution, right, and I know that's the factor of that solution, since I know the solution is negative 4, the corresponding factor I know has to be in it, right? So there should be a remainder of 0, that it does go into that particular polynomial function evenly, okay? All right, so now that I have the coefficients, I can also write this as a quadratic function. So that would be 4x squared plus 2x plus 1, right? We're going to set that equal to 0 because now it's our job to solve this, okay? And one way to solve a quadratic is by factoring. Well, if I multiply these two together, right, what multiplies to 4 but adds to 2? There is nothing. So I know another way to solve a quadratic is to use the quadratic formula. So let's do that. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, right? And this guy is a, that coefficient is b, and the constant term is c. So let's plug that in. I have negative 2 plus or minus the square root of 2 squared minus 4 times 1 all over 2 times 4. Okay, so let's simplify that. If we were to simplify that, that'd be negative 2 plus or minus the square root of, that's 4 minus 16, which is negative 12, all over 8. That should make sense. Hopefully that's, that's gratifying and satisfying based on what the graph looks like. Do I know I'm going to have imaginary solutions? Yes. And do I have a negative underneath the radical? Yes. So I know that I am probably doing this correctly, okay? If I were to simplify the radical inside, this would be negative 2 plus or minus 2i root 3 over 8. And then the last thing that I will do is I can divide out a 2 from each one of those terms. So my final answer would be negative 1 plus or minus I root 3 over 4. Okay? And I have negative 4. So I have x equals those 3 solutions. So it says state the number and the type of root. So I have 2 complex and 1 real root. All right? All right. I'm going to ask you to do this problem by yourself. Pause the video and then answer the Edpuzzle question associated with it. All right. So the answer is here. There are a couple different ways you could do this, right? I noticed that I could factor it right away, so that's what I did because I found that a little bit easier. But since they already gave you a factor, could you use synthetic division, divide that factor out of the polynomial? If you were to do that, you would get just this factor right here. So for those people that did that, I'm assuming that's what you got. You would solve that. You get x squared is equal to negative 9. Take the square root. That would be an imaginary number. And anytime you take the square root of a number, remember you always have 2 solutions. So there are 3 total roots. You have 2 complex and 1 real. All right. Pause the video. Try example letter C, and then after you do it, we'll go over it. All right. So here's the answer. Here's one thing that I think kids get caught up in a little bit. Number 1, you know that both of these are solutions because their y-coordinate is 0, so you know they are x-intercepts, and we know x-intercepts are solutions to polynomials. That's the first thing. The second thing is that we need to make sure that we break this down a little bit, because currently we cannot factor this, right? We don't have the tools to be able to factor something like that. So do you guys agree that we could divide out each one of these solutions, right? So the first one I started with was 1, right? I used synthetic division. I got to this new polynomial, right? So this is this is what I started with without the factor of x minus 1, correct? Do you guys agree with me there? Okay. And then I divided out the solution of -1 from this guy, right? Because the goal here is to get this to a quadratic, or at least to get it to something that I can factor, correct? And I currently can't factor the thing that is circled in blue, so I have to divide out another solution. So I did that. When I did that, I was left with 1, -5, and 6 as coefficients. So I rewrote that as a quadratic. And then I'm able to factor a quadratic, and in this case I am, because what multiplies to positive 6 but adds to -5, that's x minus 2 and x minus 3. I set those both equal to 0, so my solutions are x equals 2 and x equals 3, along with x equals 1 and x equals -1. State the number and type of roots. So in this case, there would be 4 real roots. And again, all 4 of these solutions, do they match up with the degree? Yes, they do. All right, last one. Can you please solve example letter D? All right, here are the answers right here. X equals 3 and x equals -1 plus or minus I root 3. Let's quickly go through that. If I were to look at the graph, again, I know that that is a solution, or a 0, because that's where it crosses the x-axis. It crosses at x equals 3. So I put 3 in my box. I use synthetic division to divide that root out to get it to a quadratic. Because again, based on the graph, I know there's only one real solution because it only crosses the x-axis one time. Therefore, I know I have imaginary solutions. And what's the only way I can get an imaginary solution? Through a quadratic equation, right? So if I divide out that solution, here's my quadratic. I use my quadratic formula, and I, in turn, get -1 plus or minus I root 3 as a solution. So I'll leave you with this. Obviously, the graphs were put on this note sheet for you because I have no way of projecting a calculator while we do these things. So the graph was put on the note sheet for you so that it was easy for you. But on your homework, it's just going to give you a polynomial, and you are going to have to graph it yourself. Do you understand? Okay. You graph it yourself. The picture is going to look exactly like this, right? I mean, not exactly like the polynomial, but it'll look similar to that, right? And then you just look for the real zeros, divide out the real zeros, get it to a quadratic, or at least get it to a thing that you can factor, and then solve it. All right? All right.